Hello everyone, this is Sanjay from the Australian Institute of Advanced Studies. Today we are going to be working on the sine and cosine rules, which are two rules that will help us solve for any triangle, the sides, the lengths of the angles within that triangle. So the sine and cosine rule, very useful for solving any triangle we have that is not a right angle triangle. So in previous lessons we've already learned how to calculate for right angle triangles using Pythagoras, but now given a triangle that isn't a right angle, we have to use these two laws or rules, the sine and the cosine rule, to solve any triangle. Now, the first step in using the sine and cosine rule is actually, first off, how do we actually label any triangle that we're given? So an example not an example, the way you should label any triangle is no matter the shape of the triangle, we all know that any triangle will have three sides. And we'll call these sides by the letters A, B, and C. Now commonly we'll use lowercase letters to represent the lengths of these sides. So this A represents the length of side A. This little b represents the length of side B, and the C represents the length of side C. The important part about selecting A, B, and C is not which one's A, which one's B, which one's C. The most important part is to make sure that your angle, which we will call A, is the opposite angle to your side length A. And that's the same for the angle B and the angle C. So what this means, how do I know it's opposite? The way I like to think about it is the angle A, which we represent with a capital A, opens up to give the side A. Angle B, with a capital B, opens up to give the side B, and angle C opens up to give the side C. Okay, so that's the first step, is label your triangles properly. A, B, and C, the matching angle A, the matching angle B, and the matching angle C. The reason we have these ABC is the actual formulas for the sine rule and understanding them. So for the sine rule, we have two variations of the same formula. We have the side length A divided by the sine of the matching angle A. So the length A divided by the sine of angle A is equal to the length B divided by the sine of its matching angle B, and that's equal to the side C divided by the sine of its matching angle C. So what this means is the ratio of any side to the sine of its complementary angle, A, okay, is equal to the ratio of any other side to the sine of its angle within a triangle. We can also flip every fraction around and we'll get another equation, which is sine of A divided by the length A equals the sine of the angle B divided by the length B equals a sine of angle C divided by the length C. Okay, so if these three are equal, then if you flip them all, then they are also equal. The reason we write these two is depending on what you're trying to find, using this equation might make your calculations easier than using this equation. I would typically use this variation of the sine rule flipped if you're trying to find an angle within the triangle. That's because the angles are given to us on top of the equation, so it's easier to move variables around and solve for that angle. I would use this variation of the sine rule to find the length of a side. So find a side length. Because here we have the lengths of the sides, A, B, and C, on the top of the equation, so it's less work to rearrange the equation to solve for those variables. All right? No matter which one you use, though, you'll still get the right answer. It's just a matter of how much work do you have to put in to get the correct answer. So the next formula we're going to learn to complete this, I'm going to erase this, but just remember that if you know this equation, then you can flip it all around and it'll be the exact same. They'll all be equal. The second rule we're going to learn is a cosine rule, which is necessary to solve for any triangle. We cannot solve every triangle using the sine rule. Sometimes we have to use the cosine rule. And the cosine rule is given to us as c squared. So the square of this side c is equal to the square of the side length A plus the square of the side length B minus 2 times the side length A times the side length B times the cos of the angle C. Okay, so c squared equals A squared plus B squared minus 2 times A times B times the cos of C. So the key here is this C should match the angle you use at the end of the cosine rule. And it's called the cosine rule because now instead of having the sine in our equations, we have the cosine of the angle C there. So the key is these C's should match. If these are A and B, then these two numbers should be A and B as well. Using these two equations, we can successfully solve for any triangle as long as we're given as many the necessary amount of values. So when I say the necessary amount of values, you will need any 3 values in a triangle to fully solve it. When I say any 3 values, in any triangle, we have 1, 2, 3 angles, and we have 1, 2, 3 lengths of the side. As long as we have 2 of the angles and 1 of the side lengths, or 2 of the sides and 1 of the angles, or even 3 of the sides, we can solve for all the other variables in a triangle. The only time, sorry, I shouldn't say any 3 values, I should say almost any 3 values in a triangle to fully solve it. Because if we have a triangle where we know A, B, and C, we cannot actually use either of these formulas to find the side lengths A, B, and C. The reason that actually is the case is, let's say I have a triangle like this, and the only 3 values I'm given are this is 30 degrees, let's say this is 80 degrees, and this is 70 degrees. I can't figure out what's this side length, what's this side length, and what's this side length, because when we only have these angles here, we could draw a triangle very small with the same angles, or we could draw a triangle that's massive with the exact same angles, 30, 80, 70, 30, 80, 70. Okay? And there's nothing to fix the length of our sides. So if you have a triangle that all you know is the angles, you could easily stretch that triangle or shrink it and change the numbers here. So there's no solution for these numbers because they could be anything. They could be very small, they could be very large. All right? So the one condition to solve any triangle is you need almost any 3 values in a triangle to fully solve it, but one value you'll definitely need is always 1 side length. Once you have the length of one side, let's say this is equal to 10 meters, it instantly fixes this length of the side, or the side of the triangle, and these 2 sides will be some ratio of that number 10. So as long as we have 1 length in a triangle, we can find the other 2 lengths, okay? And 2 angles. So as long as we have almost any 3 values, given that one of those 3 values is the side length, the other can be 2 angles, or 2 sides and 1 angle. As long as we get 3 values, we can fully solve a triangle. So let's do some examples to actually practice these skills. So let's say we're given a triangle like this. And we know that the angle here is 30 degrees. We know the angle here is, we'll do the same one as before, 80 degrees. And this angle here is 70 degrees. Okay? Now, actually, in the question, we'll say that we're only given these 2 angles, 30 degrees and 80 degrees. And let's say that we're given that the base of this triangle is a distance of 20 meters. So this length here is 20 meters. Now the question might say, find x. Okay? The key steps that I recommend to finding x, in this case, is the first step is label your triangle, okay? Because these a, b's, and c's will help us substitute in the equation to find what we need. So what I like to do, just to help me visualize it and to show it, is I'll draw the same triangle, but instead of putting the numbers in, I'll give it letters A's, B's, and C's. So I'm going to call 20 A, and remember, if we call this the side A, then the angle A has to be the angle that opens to give us the side A. Now I'm going to call X B. Doesn't matter what we call X, I can call it B because I'm trying to represent it using A's, B's, and C's. And if we're calling X B, then this angle here is the angle B because it opens up to give us the side B. Now we can label C and C as well, but there's no need because if we look at the question, we don't have the angle C, we don't have the side C, and we don't actually care about them. We're only trying to find X, which is what we're calling B. So let's do a little checklist. Do we know the side length A? Yes, we do. It's 20 meters. Do we know the angle B? Yes, we do. It's 30 degrees. Do we know the angle A? Yes, we do. It's 80 degrees. And what are we trying to find? We're trying to find the length of B, which we're calling X. Okay? So we have two equations. We know A and A degrees. We know B degrees, and we're trying to find B. So the first question is, which equation should we use? I can do a checklist, and I can just tick off what we know and what we don't know. Do we know A? Yes. Do we know the sine of A? Yes. So we know this complete side of one equation. Do we know the side of B? No, but that's what we're trying to find, right? B is X. Do we know the angle B? Yep, the angle B opens up to give B, and that angle is 30 degrees. So do we care about C or sine C? No. So we can write an equation A over sine A equals B over sine B, where we have only one unknown, right? B is the only unknown. We know the other three values, and we have one equation. If you have one equation, one unknown, you can solve the equation. So what I'm going to get here now is A over sine A. What is A? A is 20 meters. Sine A is a sine of the complementary angle A, which is a sine of 80 degrees. A over sine A equals B over sine B. What's B? B is actually X, and the sine of B is sine of 30 degrees. So we get A over sine A, 20 over sine 80 is equal to B over sine B, X over sine 30. And we can rearrange this equation to solve for X. How do we do that? We multiply both sides by the sine of 30. And the reason we've done that is the whole purpose is to cancel it on this side, or in other words, bring it to this side. So we get, on the right-hand side, we get X by itself is equal to 20 times sine 30 degrees divided by the sine of 80 degrees. Now, I still don't have a calculator on me, but what we can do is we can insert the answer here, but all you do in your calculator is 20 times sine 30 divided by sine 80, and you'll get your answer here for X. Okay? The main point here, though, is the sine rule will only ever work if in the question you're given, you have a side and at least one matching angle. Okay? In this question, it works because we had the side A and we had the matching angle A, which means using the angle B, we could find B. Okay? So what I'm saying is, to use the sine rule, you always need to complete at least one of these fractions. You need at least a side and its matching angle, a side and its matching angle, a side and its matching angle. As long as you have one pair of a side and its matching angle, and you have one other value, any of these four values, you can solve the equation. Sometimes, though, we don't ever get the angle and its matching side, and that's when the cosine rule comes into help. So, to erase all this, The next example I'm going to give is when we don't have a side and a matching angle, where we only have a side, and an angle. So in this case, let's do a triangle like this. In this triangle here, we get, let's say this angle here is 40 degrees. Let's say this side here is 12 meters, and this side here is 10 meters long, and we're going to call this distance here L. L for length. I'm just trying to change it from X. So there we go, 10, 12, and 40 degrees. Like I've always said, label your triangle by drawing another one beside it and giving it the letters A's, B's, and C's, okay? Now in this case, it's really up to you to decide how you want to label it. I would actually personally call this angle C and this side C. The reason I do that is I know that we're trying to find it using the cosine rule. But let's say you're a student, you're inexperienced with solving triangles, and so you call this the angle A. That's perfectly fine. If this is the angle A, what it opens up to is the side length A, which is actually what our L is. And then B and C doesn't matter. We can call this the side B, this is side C. If this is the side B, then this is the angle B. If this is the side C, then this is the angle C, because they open up to their respective matching letter. So what do we know? We know C, we know B, and we know A. And we're trying to find the length A. The only difference here though is, unlike the previous example, we don't have any angle and its matching side. We have the side C, but we don't have the angle C. We know the side B, but we don't know the angle B. And we have the angle A, but we don't have the side A. So we have no pair of side and angle, side and angle, side and angle. We don't have any of those pairs. So let's look at the sine rule and see why this isn't going to work. We know B, we know C, we know A degrees, and we're trying to find A. So we know B, we know C, we know A degrees, and we're trying to find A. But if you look here, we don't know B, we don't know C, right? So if you look here, we don't have a complete equation here, we don't have a complete equation here because we don't know the angle B, and we don't have a complete equation here because we don't know the angle C. So we can't use a sine rule, because if we ever use a sine rule, if I block out this side, we have 1, 2 unknowns, 1 equation. We can't solve it. If I block out this side, we have 1, 2 unknowns, 1 equation, we can't solve it. Overall, we have 1, 2 equations, 1, 2, 3 unknowns, so we can't solve it. But if you look at the cosine rule, we're very capable of solving this equation. We know A, B, and C, and we're trying to find the angle A. The side length A. So what we need to do is we need to change this equation to the lettering that we've used, right? Typically, if you're using the cosine rule, it's set up to be finding C squared, okay? But we can rewrite the cosine rule for any letter. In this case, we are trying to find the letter A, okay? So what we can do is we can look at the cosine rule, and instead of C squared, we replace it with A squared, because that's what we're trying to find. Now, instead of A squared, because we've replaced C with A, we replace A with C. So instead of C squared equals A squared, we get A squared equals C squared. The B remains the exact same, so we get plus B squared, minus 2. Now, remember how I said you replace A's with C's? Because we've changed this, we're going to replace 2A with 2C. Okay? B remains the same, and then times the cos, not the cos of C now, because remember we're replacing C with A and A with C, so we get the cos of A instead. And you see the similarities. C squared equals A squared plus B squared minus 2AB cos C, where this C squared and this C degrees matches. In our case, we have A squared equals C squared plus B squared minus 2CB, or BC, cos A, where these two A's match, these two C's match, and you just replace all the A's with C's on this side of the equation. So that's what happens if you don't start with C. Now, personally, what I would do to make my life just a little easier is when I'm labeling my triangle, it helps to be proactive to save your precious time. I would start by calling this the angle C, because in the cosine rule, the only angle you need is the angle C. And if this is the angle C, then this is the side C, which is L. And so straight away, my equation is set up for me. I have what I want to find already isolated, and I have everything I know on the other side of the equation. So let's do the checklist. Going back to our original format, we called this the angle A, this is side A. This is side B, this is side C. Okay? Let's look at our equation. We are trying to find the the side length A, which is actually L. So A squared is L squared. What do we know? We know C is 12. We know B is 10. So we know B and C. We know C and B. And we know the angle A is 40 degrees. So if you look at this equation, unlike the sine rule where we had two equations, three unknowns, in the cosine rule, we have one equation, right? One unknown, we know everything else. So if you have one equation, one unknown, you can solve the equation. So what I'm going to get here is L squared equals C squared plus B squared minus 2CB cos A, and I just substitute in the values. L is equal to, I'm going to bring that square there and square root the right hand side of the equation. C squared is just 12 squared. B squared is just 10 squared, and minus 2 times C times B, so times 12 times 10, times the cos of the angle A times cos 40 degrees. Now this is a long equation, but you can type this fully into your calculator using a set of brackets, and it'll make it very easy to do. Okay, so square root this in brackets in your calculator. I did not mean to erase that. And you'll get your answer. Now, unfortunately, I still don't have a calculator on me, so I cannot give you the answer, but we'll place it in there, the answer to this equation. So that is how you use the cosine rule. Now, one thing we haven't practiced is how do you find an angle? So we're going to do that now. So the final example I'm going to give, or the final two examples I'm going to give, is we've now used the sine rule to find the length of the side. We've now used the cosine rule to find the length of the side. How do we find the angles within a triangle? So the way we're going to do that is the exact same process. Draw your triangle, label your triangle, do your checklist, and decide on the most effective method to use. Okay? So I'm just erasing all of these. So in this example, I'm going to give you a triangle where we have this length here is 20, this length here is 30, let's say centimeters, units don't matter too much in this case, 30 and 20 centimeters, and let's say that this angle here is 60 degrees, okay? So can we solve this triangle? Yes, you can. We have 1, 2, 3 values. All you need is 3 values. As long as one of those 3 values is the length of a side, you can solve your triangle. So in this example, I'm going to say, what is this angle here, theta, which is just a Greek letter or a variable. What's the angle theta in degrees? Okay, so the question is, we're trying to find this value theta. All right, so draw your triangle, do your checklist. If this is the angle theta, let's call that the angle A. A, the angle opens up to give us side A, right? Remember, we're labeling our triangle. I'm going to call this the angle B, and B opens up to give us the side length of B, okay? What do we know, right? Do we care about C? No, because we don't know C, we don't know C, okay? So we're not going to bother writing them in, but if we did, it would be C here and C here. But we don't have those, so they're no help to us. What do we know? We know the side length B is 30. We know the side length A is 20, and we know the angle B is 60 degrees. So what is the angle A? What is theta? That's what we're trying to find. So the way we're going to do that is, remember I said the sine rule is only useful if you have a side length and its matching angle, at least one pair. Here we have the side B and the angle B, which means we have completed one of these equations, which means the sine rule is probably the best option to use. The cosine rule is not that useful, right, in this case, because where are we? B and A. Yeah, because in this case we're trying to find the angle A, so that's like finding the angle C if you were to equate it to the cosine rule. The other two sides being B and C. Yeah, so the cosine rule won't work because we don't know two things in the equation. Okay? So we'd use the sine rule anyway because we have a side length and its matching angle. What are we trying to find? We know the length A as well, and we're trying to find the angle A, right? We're trying to find that angle A. Now, at the start of the lesson, I said that you can rearrange a sine rule by flipping each side. So we're trying to find the angle A, so rather than keeping it on the bottom of the equation, we can put it to the top of the equation. So to do that, we'll get the sine of A over A equals the sine of B over B. Do I write C over sine of C over C? I could, but there's no point because we don't know C or the side C. Okay? So sine A over A equals sine B over B. I should write that a little neater, but it doesn't matter. What's the sine of A? When we labeled our triangle, we called A theta. So we can put theta back into the equation. What's the length A? It's 20 centimeters. What's the sine of B? It's the sine of 60 degrees. And what's the length B? It's 30 centimeters. So all we have to do now is, just like before, we bring that 20 over to this side. If it's divide by 20 on the left-hand side, it becomes multiply by 20 on the right-hand side when you move it. And we get the sine of theta is equal to the sine of 60 over 30 times 20. The only issue here, though, is the sine of theta isn't enough. The sine of theta is a number, but we still want to find theta, right? The sine of theta is not the same as theta by itself. So what we do is we bring the sine to the other side of the equation as well. But there's a special way to do that. By bringing sine over, it becomes sine inverse of whatever we have on the right-hand side already. So if you have the sine of theta equals sine 60 times 20 over 30, then theta by itself equals the sine inverse of whatever was on that right-hand side. So 20 times sine 60 over 30. 20 times sine 60 over 30. The sine inverse of that. Now, all you have to do is type that into a calculator and you'll get the answer, which we will insert here. But the way I would personally do it is you can write this all at once in your calculator. You can press the shift button on your calculator and then press sine to get sine inverse. You can write a set of brackets, and in your brackets just write 20 times the sine of 60 over 30, close the bracket, type it all at once, you'll get your most exact answer. If you don't do that, you might have some rounding errors. Okay, we might say that this value here, when we round it, is 0.83, but in reality, if we didn't round it, it's 0.83116 up for ages. If we use this number by typing it all at once, we'll get the most accurate answer. Okay, so that's how you find the angle using the sine rule. You can also find the angle in any triangle using the cosine rule. And the way we're going to do that, remember the cosine rule is what you use when you don't have an angle and its matching side. Okay, so in this case we can do a triangle like this. Let's say that I know this length here is 12, this length here is 10, and this length here is 8. And I wanted to find what's this angle here. We're going to call it C. Okay? How do I find the, actually let's not call it C, let's make it fun. Let's call it alpha in degrees. How do I find that angle here? Remember, label your triangle. A, B, C. If that's A, then this is the angle A. If that's B, this is the angle B. And if that's C, then this is the angle C. Okay? Do we care about the angle B? No. Do we care about the angle A? No, we don't. We're trying to find the angle C. The reason I've called this the angle C, alpha as the angle C, is we're going to be using the cosine rule, and the cosine rule, the way we write it initially, already has the angle C in that equation. So let's do our checklist. We know A, we know B, we know C. Okay? We know A, we know B, we know C, and we're trying to find the angle C. If you look at the cosine rule, we know A, we know B, we know A, we know B, we know the length C, and we're trying to find the angle C. We have one unknown, one equation, so we can solve for that angle C. The way we have to do that, though, is we have to rearrange the cosine rule to solve for the cos of C, and then we have to rearrange again to find the actual angle C. The way we do that is some simple maths is we'll bring, well, I'll just write it again. C squared equals A squared plus B squared minus 2AB cos of C. The way I would solve this is I'd bring minus 2AB cos C over to this side, and I'd bring positive C squared to this side. If you bring negative 2AB cos C over the equal sign, it becomes positive 2AB cos C equals A squared plus B squared. Now we've gotten rid of that, and we brought C squared over. It was positive on the left-hand side, so it becomes negative on the right-hand side. Now what we have to do is we divide both sides by 2AB, divide by 2AB. The reason we do that is it'll cancel on the left-hand side, and we get the cos of C is equal to A squared plus B squared minus C squared divided by 2AB. All that is from rearranging this, where we know ABC, AB, so we know this whole side of the equation, which means we can solve this side. The final step, though, is we don't want the cos of C, just like before. We want C by itself. What's C? It's actually alpha, so let's write that in. Alpha, okay? And to get it by itself, we have to bring our cos function to the right-hand side. Bringing your cos function to the right-hand side turns it into a cos inverse function, just like we had sine inverse before. And in the brackets, we just get this right-hand side here. A squared plus B squared minus C squared over 2AB. So alpha is equal to the cos inverse of A squared plus B squared minus C squared over 2AB. And once you have this formula, it's just a simple matter of plugging in your numbers and solving for alpha. So what's A? A is 8. So it's 8 squared. What's B? B is 12. Remember, we called alpha C originally, so this is the side C. That's important. The angle has to match the side that you're subtracting. So we minus C squared, we have to minus that 10 squared because it's a matching side to our angle. Divided by 2AB is just 2 times 8 times 12. A and B, 2 times 8 times 12, okay? And the final answer we get is you plug it into your calculator and you'll get alpha degrees equals the cos inverse of that number there, which equals the answer which we will insert into the video here, okay? There you go. That's how you found the angle alpha. So just to revise, we've now covered the sine and cosine rule. The sine rule is only useful once we have at least a side and its matching angle. A side and its matching angle, side and its matching angle. The cosine rule is useful when we have no pair of side and its matching angle. We can use the cosine rule. Using these two rules, we can solve for any triangle, we can solve for any side in a triangle, and we can solve for any angle A, B, or C in a triangle as well. All right? So one final example I'm going to give. Actually, I think that should cut it for now. But one challenge question I would recommend solving is, let's say we have a triangle like this. And this side length here is 20, and this side here is 18, and this angle here is 30 degrees. And then let's say attached to the side of this triangle is another triangle, like this. They're not symmetrical. And let's say this is the angle 30. That's that side. And let's say that this length here is 10. So this length here is 10. And this angle here is 100 degrees. And the challenge in this question is to find this length x. What's the length here? X. So the way we're going to do that is, and I'm not going to do it for you, but I'll give you a hint. How can we solve this triangle? Well, let's think about it. We need any three values as long as one of those values is the length of a side. So if we look at the right triangle, we have one side, so that's satisfied. We have one angle, so we have two values, but we don't know this x, we don't know this angle, we don't know this angle. So we only know two values in this right triangle here, right? So we can't solve it. You need three values where one of them is a side, which is satisfied, but we only have two at the end, to solve a triangle. In the left triangle, or the lower triangle, we have two sides and one angle. That means we have three values, any three values we need, and one of them is a side, so that's good as well, so we can solve this triangle. What's going to happen is once we solve this triangle, right, we know this length here. If we solve the triangle, we can find this length here. If we know this length here, we now know 1, 2, 3 values in our upper triangle, and if you know three values in a triangle, you can solve for everything else, so we can solve for x. So to solve the lower triangle, I would use the cosine rule. The reason I would use the cosine rule is we have a side, but we don't have its matching angle. We have this side, we don't have its matching angle. We have this angle, and we don't have its matching side. If you don't have any pairs of sides and matching angles, then you can't use the sine rule to begin with. You have to start with the cosine rule. Once you've used the cosine rule, you might have a side and its matching angle, and then you can start using the sine rule. But if you have no matching pairs of sides and angles, you have to use the cosine rule first. So we can use the cosine rule to solve for this distance here. I'll leave that up to you to try to solve. Once we solve that value here, let's just call it c. We can then solve for x because we can use the cosine rule again to solve for x. I did actually write this question wrong. I'd like to change it. If this angle 100 degrees wasn't given, but this angle here 30 degrees was given, we can solve for x somehow. Let's see. Yep, 30 degrees. Sorry, I would keep this actually. This would be 100 degrees, just like I did before. I didn't mean to erase that. We would find C. Once you have C, you'd have your matching angle C, because this 30 degrees opens up to give us the matching side C. And you'd have C and the angle C, which means for the upper triangle, you could use the sine rule. Using the sine rule, we'd have C over sine 30 equals x over sine 100. So in the first case, how do we find this value C? Using the cosine rule, we'd use c squared equals a squared plus b squared minus 2ab cos c. A is 20. B is 18, so 20 squared plus 18 squared. A is 20, B is 18, and times the cos of C, where C is 30 degrees. C squared equals all of that, so C equals the square root of all of that. We get our answer. That equals C, right? Now that we know C, we can look at this triangle here where we have an angle and its matching side, an angle and its matching side. So the way we're going to do this is we're going to solve this upper triangle using the sine rule. Okay? And the reason I say that is once you know C, you know the matching angle C, we have x and we have the matching angle x. We know C, we know the matching angle C. Okay? We're trying to find the distance x. So C, which we've calculated as C over the sine of C. What's the sine of C? If this is C, this is the angle C, so the sine of C is sine of 30 degrees, equals x over its matching angle, the sine of 100. Okay? And the final answer we're going to get is we bring that divide by sine 100 over, and we get x equals sine 100 times by c divided by the sine of 30. Now, all you need to do is calculate your value of c using the first equation, put that number into here, multiply it by sine 100, divide it by sine 30, and you've gotten your answer x. So there you go. That is the sine and the cosine rule. A over sine A equals B over sine B equals C over sine C. You can flip it around if you want. C squared equals A squared plus B squared minus 2AB cos C. And one extra, just to make it easier for you to remember, is that C, the angle C, is equal to A squared plus B squared minus 2AB over A squared plus B squared minus C squared over 2AB, and it's the cos inverse of that there. So C squared equals A squared plus B squared minus 2AB cos C, and C, the angle, is equal to the inverse cos of A squared plus B squared minus C squared over 2AB. So using the sine and cosine rule, we can solve for any triangle as long as we have three values in that triangle, and one of those three values is the length of a side. And there you go. That would be the lesson. Label your triangles properly, do your checklist. If you have a pair, use the sine rule. If you don't have the pair, you can use the cosine rule, and then you can use the sine rule if you need to. And that'll help you solve any triangle. Actually, one more point I'd like to say is, you may have heard that in a right angle triangle, we have A, B, and C. And you might know the formula that C squared equals A squared plus B squared for a right angle triangle only. The reason that's the case is if you think about it, what's that angle there? That right angle means the angle is 90 degrees. That means 90 degrees, if this is the side C, the hypotenuse, then the angle that opens up to it is the angle C, right? So if we use the cosine rule, we can actually say that C squared equals A squared, whatever it might be, plus B squared minus 2AB times the cos of C. But because it's a right angle triangle, you always know that the cos of C is 90 degrees, so we can actually put in cos 90 degrees. And what you'll find is that the cos of 90, cos is related to the x coordinate, so it will be 0. You'll get A squared plus B squared. We know that the cos of 90 is equal to 0. So 2AB times 0 is just 0, so you get minus 0. That goes away, and we get C squared equals A squared plus B squared. So what that means is that Pythagoras' theorem for the hypotenuse of a right angle triangle is actually derived from the cosine rule. And that's why the cosine rule will work in any right angle triangle, any triangle whatsoever. Okay? Perfect.